Hello children, let us start working out sums on trigonometric identities. Before that, quickly we will see have a review about trigonometric identities. So, first one, sin square theta plus cos square theta equal to 1. This can be written in these two format. Secant square theta minus tan square theta equal to 1, and cosec square theta minus cot square theta equal to 1. From these only we will be having this secant square theta equal to 1 plus tan square theta. Tan square theta equal to, you move this transpose to RHS, this will come to LHS. Similarly over here. And one more thing, most commonly we'll be using tan theta equal to sin by cos, and cot will be using as cos by sin. And some more important things we need to know here is cosec theta is 1 by sin theta, that is cosec into sin is 1. Then next secant theta equal to 1 by cos, secant into cos is 1. And these are the identities, algebraic identities will be requiring. Here a plus b whole square I have written in two form, either a plus b or a plus b into a plus b, or a square plus b square plus 2ab. Now the same thing over here, one more, a square plus b square equal to a plus b whole square minus 2ab. So whenever and wherever required we will be using these identities. Now we get started with, now we'll solve with exercise 8.4, fifth main, page number 193, NCERT textbook. First sum is cosec theta minus cot square theta equal to 1 minus cos theta 1 plus cos theta. So here cosec is written as 1 by sin theta minus cot is written as cos theta by sin theta whole square. This one 1 minus cos theta here whole square, we are giving the square to numerator as well as denominator. So 1 minus cos theta whole square and divided by sin square theta. Now here we will put it this one cos theta and 1 minus cos theta. I have split this as 1 minus cos theta, a minus b whole square as a minus b, a minus b. Why? Look at the question, it is 1 minus cos theta what we require. So this is sin square theta, we will write it as, one more thing here, we don't need sign in the question, so we will be substituting it here as 1 minus cos square theta, the identity part. So here numerator as it is cos theta, and this is 1 minus cos theta. Here denominator, make this as a square minus b square, a square minus b square, a plus b, a minus b. Cancel this, so therefore 1 minus cos theta divided by 1 plus cos theta proved. We'll move on with the next sum. Second sum, cos a 1 by sin a. Now here binomial, put bracket first, then denominator, treat this as fraction, a by b plus x by y. So these two we have to take LCM. So LCM will be the same thing, 1 plus sin a into cos a. Here numerator, look, 1 plus sin a, 1 plus sin a here. So cos a is missed. So we'll multiply this one as cos a. So this becomes cos square a plus, here in this one cos a is there, cos a, this bracket, and this one when we multiply it will become 1 plus sin a whole square. So here again whether we have to put here 1 plus sin a or into 1 plus sin a, or we have to expand it. Look, the question will tell us we have 2 over here, so that 2ab we will get it in that part. So first I will put here cos square a, this one as it is, plus a plus b whole square, formula we will be using a square plus b square plus 2ab. A here is 1 into sin theta, denominator let it be as it is. Cos square theta sin square theta is 1, identity 1 square is 1 plus 2 sin a divided by 1 plus, usually in trigonometry identities, denominator carry it as it is until you fully solve the numerator part. So 2 here, 2 plus 2 sine A divided by 1 plus sine A cos A. Take 2 common out, here it will become 1 plus sine A divided by 1 plus sine A into cos A. Cancel this. So what is remaining finally? 2 divided by cos A. So you can write directly answer or see. Initially 2, 1 by cos is secant A. Done. So this is our second sum. We'll move on with the third one. Now this is our third sum. Here we have to prove tan theta by 1 minus cos theta plus cot theta by 1 minus tan theta equal to 1 plus secant theta into cosec theta. Now again one more thing. Here this is secant and tan. 1 by cos, 1 by sine will be taken as secant and cosec. So this here, this is in the form of tan and cot, and no square in this sum, so no identity initially can be applied. So we'll bring this to simple form. Tan I have taken as sine by cos, 1 as it is, minus cot is cos by sine. Same way here also you substitute. Cot is cos theta by sine theta divided by 1 minus tan is sine theta divided by cos theta. Here put 1 by 1, it would be easy for LCM. Treat this two parts separately initially first. We will solve this part. Here look, take reciprocal. Here we'll take LCM, then reciprocal. Sine theta by cos theta as it is, main division line down, denominator 1 minus sine theta, 1 and sine theta is LCM. Here it will be sine theta 1, so here minus, this is into 1, this is into sine theta, it will be cos theta. This plus sign bring it down as it is, cos theta by sine theta. Again here LCM is cos theta, here you multiply this, it will be cos theta minus sine theta. Now again as I told, we will take reciprocal over here. Sine theta by cos theta into this one, main division line will become multiplication. We get reciprocal like this, plus same here, cos theta by sine theta into cos theta by cos theta minus sine theta. Here nothing cancels, do not cancel here, sine into sine, this becomes sine square theta cos theta into sine theta minus cos theta, plus cos square theta by sine theta into cos theta minus sine theta. Now again we come across a fraction, again we'll have to take LCM. To take LCM, look here, cos and sine we can take it as cos and sine. Sine theta minus cos theta minus sine theta. These two brackets are not same, though the trigonometric ratio are same over here. Now sine is positive, sine is negative here, cos is negative, cos is positive here. If both bracket were same, so common thing we would have taken one time. So for that what we will do, from this bracket we will take minus sign common out. Look here, sine square theta cos theta, this part write as it is, this plus as it is, numerator, then here I take minus common out. So when I take minus into cos, it will be cos theta, so minus into minus you should get plus here, then minus sine theta, minus into sine theta you get back this one. Now what we will do, we will take this plus and minus, this sign will become minus, sine square theta cos theta into sin theta minus cos theta minus, now this plus becomes minus cos square theta, here sin theta, this minus has gone there, so sin theta minus cos theta. Now next part, look, now it is easy for us to take LCM. Here I will take 1 time cos theta, the single term first, and then you take this sin theta here. Now look, this bracket and this bracket is common, so common thing 1 time LCM. Now here look, this is cos in LCM, then this bracket is there, which is the one missing here, sin. So here we'll multiply this with sin theta, so this becomes sin cube theta minus, then this side it will be, this is sin, so this is sin, bracket, this cos is missing, so we'll multiply. These are actually the rules of LCM only, just for you all to be easy I am showing in this way. Now we got it as here a cube minus b cube, a cube minus b cube formula will be, so I will apply here a cube minus b cube formula, a cube minus b cube formula, it is a minus b, then a square sin square theta plus cos square theta plus a into b. Let denominator be as it is. Until we simplify numerator, we keep on carrying the denominator. Look, this cancels. Then next step, sin square theta plus cos square theta 1 plus sin theta into cos theta, here cos theta into sin theta. Done. Now here what we have to prove is, we have to prove 1 plus secant theta and cosec. Secant is 1 by cos, here cos and sin are together already, but here we will split up the LCM. These are the things just to make sums easier for this one also, and for this term plus is separator, 2 terms for this cos theta sin theta, and this main plus sign here, then sin theta cos theta, so cos theta into sin theta. This is one previous step of taking LCM. This is LCM taken, this one you can check out LCM, you get back the same thing. Now this will cancel and become 1. 1 by cos is what? Secant theta. 1 by sin is what? Cosec theta plus 1. So we got our answer 1 plus secant theta into cosec theta, and prove. So children, do not forget, this is the main step over here where you take out minus sign common out. This is the main step, rest all the same. Simplification is easy. Fine. Next we will move on with the next sum. Fourth sum, 1 plus secant a, secant by secant a equal to sin square. Now here you can see this is not in square term, so what we'll do, we'll bring it into simple form. Initially we'll start with this one LHS, try proving it equal to RHS, and let's see what happens. 1 plus 1 by cos a, this make it 1 by 1, then this is 1 by cos a. Here numerator LCM will be cos a, this one, so this will be into cos a into 1, so this becomes cos a plus 1, denominator as it is. So you can cancel this cos a and cos a, you get cos a plus 1 divided by 1. Here look, after this step we do not have any other way to proceed next. So when we come across this type, Then what we'll do, we'll leave here LHS as it is, and then we'll prove RHS. So whenever we call this as a blind step, where further you cannot do, you can proceed by taking here one as sine square cos square, but the easier one will be proving LHS and RHS separately. So LHS we got it as cos A plus 1. So we'll take RHS sine square A divided by 1 minus cos A. Remember, this also we'll have to bring it up to cos A plus 1. So sine is not required. I will put it as 1 minus cos square A divided by 1 minus cos A. Now A square minus B square. So this will become 1 minus cos A 1 plus cos A. We have used A square minus B square equal to A plus B, A minus B formula here. Then denominator as it is. Now this and this cancel. We get 1 plus cos A. So this is also, therefore we write here LHS is equal to RHS. Cos A plus 1, 1 plus cos A, both are same. So when you come across this type of steps, prove LHS and RHS separately. We'll next move on with fifth sum. The fifth sum, cos A minus sin A plus 1, cos A plus sin A minus 1 equal to cosec A plus cot A. Now first, before getting started with this sum, let us see how we have to start it, or what are given things over. This is cosec A and this is cot A. No square over here, no identity can be put to for this. This already is in the simple format, that is in the form of sine and cos. So we cannot do and no further simplification or no identities, because they are not square terms. So one thing, this is very important sum. For 4 marks it will be given. Here look, cosec is what? Cosec is 1 by sine. Look, cosec is 1 by sine and cot will be 1 by tan, or cot here will be in the form of cos by sine. So both are divided by sine. So this is a major trick or technique to remember. 1 by sine, cos by sine. Denominator is sine. So divide each term. Divide each term by sine A. So if it was secant, then it would be cos, then this will be tan. So we will divide throughout by cos then. But now we are dividing each term in LHS by sine theta. Try to understand, it is very simple. Sine A by sine A. Divide each term, even 1 also, by sine. Only LHS side. Denominator cos A by sine A plus, be particular with the question or the signs, sine A minus 1 by sine A. Now this becomes here, cos by sine is what? Cot A. Cancel, this becomes 1. 1 by sine is what? Cosec A. Here also cos by sine is cot A, plus cancel 1 minus cosec A. I hope you got this one. This is a starter. Rest all you can do it later. We will reshuffle here only. We will send this one at the end. Cot A plus cosec A minus 1 divided by cot A minus cosec A plus 1. Remember, no terms get cancelled. They are connected with plus or minus sign. Now again we have a problem here. There are no square. Again, if we bring this sine and cos, we come back to this question back. So what we will do here, this one, for this one or this one, any one, here numerator we will apply identity which connects cot and cosec. Look, what is the identity? Cosec square theta minus cot square theta equal to 1. So in place of 1 we will substitute, look, cot A plus cosec A minus, don't forget to put bracket, it is cosec square theta A minus cot square A. In place of 1 we have substituted the identity. Now you might be asking, how do we know whether here only we have to substitute the identity? This comes with the practice. Solve more sums so that you will be able to identify where the identities have to be put. Now cot, this one again no change, this no change. Here you look on, it is a square minus b square. Treat this as a square minus b square. It becomes a plus b, then cosec a minus b. Look here, understand this. A square minus b square, a plus b, a minus b. Bring it, cot a minus cosec a plus 1. Now we'll put square bracket because this minus sign is here. Now most important step over here. Now see this part, I'll make it easy so that it will be clear for you to understand. If it is x plus x into y, x plus x into y, what do? Take common out x, then this will be 1 plus y. Fine. So got it, this one. Same thing we are doing here. Look, this whole thing, treat this as x, so this also is x, and this will be as y. Imagine this is x, x and y. We will take this common out, the whole bracket, that is cot a plus cosec a. Bracket common out, this and this bracket is out, this will be 1. Here this is out, 1. This minus sign over here minus, still we are inside the bracket cosec a minus cot a as it is. X minus x into y, x common out, 1 minus y, like that. Just to understand, I have given x and y, do not write it. Next, denominator, as I told you before, do not simplify, just bring it as it is down. Open up bracket, here you get cot a plus cosec a, then here 1 minus cosec a plus, minus and minus plus. That's the reason I have been telling you to put bracket. Now check out denominator. You can write one more step here, bringing it to this format. Now check here, this whole bracket, cot positive, minus cosec, plus 1, plus 1. So this whole bracket get cancelled. So we get, therefore, cot a plus cosec a. Done. Hence proved over here. Hope you understood. If at all you have not, pause the video, rewatch it, which step you are getting stuck, so that it will be clear for you to solve this one. This is most important sum. In example sum also, in place of cosec and cot, it is secant and tan. Try doing that sum also. So we'll move on with the sixth sum. Now sixth sum, we have to prove square root of 1 plus sin a, 1 minus sin a equal to secant a plus tan a. Now secant a, tan a, again no square. Here remember 9th standard, rationalizing denominator. In this case we call it as rationalizing or compando and dividendo form. That means you can rationalize either numerator or denominator here. So now I will be taking here 1 plus sin a divided by 1 minus sin a into 1 plus sin a divided by 1 plus sin a. This is under the root. Now here we get 1 plus sin a whole square, 1 plus sin a, 1 plus sin a whole square. A minus b, a plus b will become a square minus b square, and this is under the root. Now next here, 1 plus sin a do not expand, we can cancel the square and square root, but look in denominator, it is 1 minus sin square a. 1 minus sin square a is cos square a. So now when we cancel root here, square and square root cancel, we come out of the root, here we get it cos a. So we came up to this point where further no identities can be applied or nothing, simplification can be done. Now go back and check to the question what we need actually. Secant is 1 by cos and tan is sin by cos. Look, we got it here. We say this one as splitting LCM for cos to this, cos to this. So 1 by cos A plus sin A by cos A. So you get here 1 by cos A is secant A plus tan A. Hence proved. Simple sum. Okay, let us move on with the next sum.